Hello, this is Jim McKeith, and welcome to this webinar from Embarcadero Technologies on Introduction to Developing for Chrome OS with Android and Linux. We'll be looking at mostly Delphi, but also CBuilder today. Real quick, I'm the Chief Developer Advocate and Engineer from Embarcadero Technologies, longtime software developer. Always love finding new platforms, new technologies, and new ways to push the envelope of software development. Here's our agenda. We're going to kind of look at an overview of Chrome OS and then talk about some of the Android compatible Chromebooks. Not all of them are Android compatible. And then look at how to put those Chromebooks, Chrome OS into developer mode, install and connect to ADB, and then with your Delphi apps, create resizable apps on Chrome OS, and then also look at some of the OS development concerns that you might have. And then we'll also look at how to install Linux on Chrome OS or enable Chrome OS for Linux development. Finally, we'll finish up with a summary and a look to the future. I'm assuming you probably know a little bit about Chrome OS being here, but I thought I would provide a little overview of it. It's Google's entry into the OS world, kind of works on the idea that really you're spending most of your time on your computer in your web browser. And I would say when I'm not editing video or developing, I am in my web browser probably most of the time. So that's kind of the idea behind the Chromebook, is it's a OS based on their Chrome browser. Most Chromebooks use ARM CPUs. And actually, I was surprised. Originally, I wrote this, and then I did some more looking, and there's a lot of them that are using non-Chrome CPUs or non-ARM CPUs. And the one I'm going to be using is an Intel CPU as well. So I think most is probably accurate, but it's not, it may not be the majority. It's hard to say for sure. It's kind of halfway between a laptop and the tablet. The price is really affordable. You're looking at usually from $100 to $400 for most of them. I saw a used one that had Android support in beta channel available for sale just the other day for $100. So they're really, really affordable devices. They do support offline and local storage as well as cloud, working in the cloud. They have usually decent sized storage, or you can put an SD card in them as well. They're not exclusively made and sold by Google, although Google does have some Google branded ones. They're also by third parties, much like how Google deals with Android. They are based on the Chromium OS. So Chromium is the open source version of the Chrome browser, and Chromium OS is the open source version of the Chrome OS browser. And you can find more information about that at the chromium.org website. And then Google's Chromebook page is available there, google.com/Chromebook. So why should you care about Chrome OS? If you don't have a Chromebook, why should you care? As I said earlier, they're very, very affordable computing options. And that's resulting in them getting really popular in schools. Google's actually targeting schools specifically. They have a number of initiatives around helping schools get them. They have some software specifically around schools managing courseware and educational stuff through Chrome OS. So they're really, really taking off in schools. They actually outsold Apple MacBooks last year, May of 2016 per IDC. So I did not know that. They're really quite popular apparently. They're also a super safe OS. So they're great for people that you're always over there trying to help them get viruses off their computers. Chromebooks are a good option there. Plus, there's some desktop and set-top and dongle variants of Chrome OS, so they're not all Chromebooks, the tablet, laptop type thing. There's a number of device options out there. And Neverware is a company that's making or repackaging Chrome OS as what they're calling cloud ready. So it's, I guess, the repackaging Chromium OS would be probably a more correct term there. And then they're making it so you can install it on existing systems. So it's really taken off, seeing a lot more activity around it. As far as Android compatible Chromebooks, this was announced in May of last year, 2016 at Google I/O. They announced plans to bring Android Play to Chrome OS. So they're promoting it around Android Play because for, users, that's really what it is. It gives them access to everything that's in Android Play, the Play Store. From a developer point of view, what that means is that it can run Android apps. So slight nomenclature issue there, I guess. In January 2017, Google confirmed that all Chromebooks launching in 2017 and after will support Android apps, either immediately or in the coming future. And that was at CES, where Google announced 2 new Chromebooks built around this idea of Android plus Chrome OS. Those 2 Chromebooks actually, this is a list of the Android compatible Chromebooks that you can find the complete list down there at chromium.org. I looked and priced these Chromebooks, and the Samsung Chromebook Plus and Pro are probably the 2 best ones out of that list, because they're newer ones. The other older ones, the other ones aren't that much cheaper, and they're harder to find sometimes. Plus the Samsung ones are much newer. Now in the beta channel, which is the column on the right there, some of those are actually, really nice Chromebooks as well. I think it was an Acer Chromebook 11 that I found for $100 used the other day. So, and those are in beta channel. So you have to put it in developer mode, switch to beta channel, and then you can get support for those. They have documentation on the Chromium website on how to do that. So the 2 Samsung ones are the Plus and the Pro, the Samsung Chromebook Plus, Samsung Chromebook Pro. They're both roughly the same specs, except for the CPU and the price, and the body color. The Pro is the dark color, and the Plus is a silver color. The Plus has the ARM Hexacore Rock chip, whereas the Pro has the Intel Skylake Core M3. I think I've read that there's some difference in the antenna as well for the wireless, but I don't remember the details on that one. I went with the Pro, which is what I'm demoing with, because I figured if the Pro works, then I know the Plus will work, because the Pro is, of course, using libhoudini for ARM compatibility on 64 with this, because it has a 64-bit Intel CPU, whereas the ARM, that's just another ARM CPU. All the ARM CPU Android devices out there work with Delphi and C++ Builder just fine. Well, all the ones in the past, 2 or 3 years, because the Neon instructions are now standard part of ARM CPUs. So first thing you need to do is put Chrome OS in developer mode. That link there will take you to a page where I've outlined all the steps that you see here, and the second link is going to give you some more information about that as well. It varies from device to device, but these steps seem to be the more popular steps on current devices. Here's the Samsung Chromebook Pro with the Intel processor, and I've added my little Android sticker here because Android's cool. We're going to put this into developer mode. The process I show you should work on most of at least the recent Chromebooks, but it does vary from some Chromebook to other Chromebooks, so do check for your particular model. It should work with both the Pro and the Plus. The Plus is the ARM processor and has a silver case. So we press... you don't have to, you can do this right away when you first get it or after you set it up, but the problem is it wipes your data. So might as well do it right away. So escape, refresh, which is in the position of the F3 key, and the power button, which is either right here or in my case is right here on the side. Reboots it and comes up to this scary looking screen, which is the recovery screen. So the recovery screen is where you would recover Chrome OS. You'd put some sort of removable media in here that would recover Chrome OS if something happened to it. But we're going to use it going to developer mode. So we do that by pressing Control D, which isn't on the screen. You have to know that's what you want to do. Or to turn OS verification off, press Enter. Your system will reboot and data will be cleared. So OS verification is off, and this process takes a while, as is, I'm not sure going back is pretty quick. If you turn OS verification back on, it's pretty quick. But it takes a while to turn it off. So you press Control D here again, and every time you boot it from now on, you have to press Control D, and that puts it into developer mode. And notice I have a little timer running up here in the corner. This does take a while. Last time I did it, it took about 20 minutes or half an hour or something like that, I think. So I'm not going to make you watch the whole thing, but just know it does take quite a while. Oh, wait, up here it says ETA 4 minutes, 17 seconds. Wow, so it's thinking it's going to be quicker this time. I guess we'll find out. So we're 6.5 minutes in, and now the ETA has gone up to 5 minutes, 11 seconds more. So it would appear that this is a dynamic estimate as it goes, and it may end up taking closer to 20 minutes or 30 minutes like it did last time. I don't recall the progress bar being there on the top last time, so maybe I've updated it since then. But anyway, it is definitely taking longer than originally estimated. Well, I lost track of how long it took and it's up in the other room, but I'm assuming it's finished now. So I'm going to go ahead and set up this like normal. At a point, though, it will ask me for my root, to set up a root password. When you're ready to set up ADB, there's a link there that'll take you to the page that describes how to do that. One time you have to go through in the terminal shell and set it up to set up the firewall to let ADB through. And it sets it up through port 22, which is the port used for SSH. And then you have to go into the Play Store, manage Android preferences. Well, you have to enable Play Store if you haven't done that yet, manage Android preferences, and then from there you're going to be in the Android settings screen you're familiar with. Go to About, tap the build number until it says you're now a developer, then go back into developer options and turn on ADB. To access the terminal, I just hit Control-Alt-T. It brings up Chrome browser, and this takes me to Crosh. Crosh is a limited terminal, I guess. I'm not sure exactly what the purpose of Crosh is. There's some things you can do here at this level. But to do the serious stuff, you type shell and drop down to the actual terminal shell. So we're going to look at how to do enable ADB at this point. First we have to do is we have to configure the firewall, and we can do that with sudo that should be equals 0. There we go. And notice I did not have a root password required. You can go to the virtual terminal 2 if you want to provide one. Sudo I typed something wrong here. Oh, there's too many X's in libexec. This is all documented in the blog post. Still not found. All right, let's try this again. Oh, it's USR. Ah. I get used to typing one thing in my brain. My fingers just type it. Okay, so there, it worked that time. So now we're going to reboot. Which you don't see the rebooting, but it is rebooting right now. It's displaying the OS verification's off. Space to re-enable, or Control-D, which it doesn't tell you, is how you get back in again. So every time you reboot, you have to do that. For rebooting, it goes right back into the Crosh. And so we have one last tab to run. And this time we'll spell user correctly, USR. And that's what happens if you don't type shell first. So there we go. Now we've enabled the firewall to allow Android through, or ADB through. So to turn on ADB in debug mode, we come on here and click in the system tray and click on the gear here. And scroll down and find this right here. Enable Google Play Store on your Chromebook. And this turns on Google Play support. If you don't have that option there, then your Chromebook doesn't support Google Play. But if you do get on a developer channel, which you can now that you're in beta channel or developer channel, now that you're in developer mode, you can do that. Then you might have Google Play support. There's an article I've linked to that lists all the Chromebooks that support Android in different stages. So it's going to take me into the Google Play Store. Not where I need to be right now, so I'm going to go ahead and close this. And right here, I can manage my Android preferences. That's what I need to do. And this takes me into Android settings, which if you've ever enabled an Android for debug mode, you're familiar with this screen. Come here to About Devices, and we tap on the build number, I don't know, 10 times, something like that, until it says, you are now a developer. Come back out, and now we have developer options. So come down here and turn on ADB debugging. Yes, allow ADB debugging. To connect to ADB, I need my IP address. So I just type if config and we see right here 10.0.1.36 is my IP address. So now we jump over to our development machine and connect to it. My development machine, I'm just going to jump into PowerShell or terminal command window, whatever you want to call it. And we're going to do ADB connect 10.0.1.36. And we need to specify port 22. The default port will not work. You have to use port 22 because that's the way the firewall is set up. And that's the way ADB is set up. So now back on our Chromebook, we get this message here to allow ADB debugging. And it gives us our RSA fingerprint, which I don't know about you, but I have all my RSA fingerprints memorized. And there we go. Now we've enabled ADB debugging. So we'll fire up our favorite development tool. Create a new multi-device application. Switch it to Android. And Caroline is there, which I don't know if you saw when I was in the screen to enable developer mode, it said that the version I was running was called Caroline something, something, something. So that's the version of Chrome OS I'm running on my Chromebook. So let's go ahead and add an edit box on here and a label. And the label will change it to say something useful like, hello, Chrome OS from Delphi. It helps if I'm sitting in front of my keyboard, sit off to the side. And we'll run it on our Chromebook. So there we go. It's coming up. For some reason, I'm getting some major lag in my screen mirroring software. And one thing, so here it is. It's running. It's in a ring in a window. But so by default, Android apps built with, depending on what version of Android they're built with, will run in a phone-shaped window like this. I come in here. And so actually notice that, oh, you can't see my mouse cursor. There's an offset between the mouse cursor and where I'm actually tapping. So I'll show you about that in a second here. So I'm going to say hello world, or hello, yeah, we'll say hello world. And now I'm going to resize this. Which is going to say, whoa, we have to restart your application to resize it. So now it's full screen, but you notice my hello world's gone because I had to restart the application. So this isn't really an ideal experience. So let's look at what we can do to fix that. So as you are developing apps, you're going to want to make sure your apps resize, which is simply a matter of making sure you're using SDK version 24. So that's just a matter of running the Android SDK manager and downloading the latest SDK. And then in your Android manifest, you need to change that line there, you see, to say uses Android min SDK version equals 24. And this will tell the OS that you understand how to be resizable. Now, you're going to also want to add save state persistence to your application, which is really easy to do. There's a DocWiki page on it there. And also on Intel Chromebooks, for some reason, libhoudini causes an offset of touches. So the touches are a little bit lower than they should be. And the difference is the height of the status bar. And if you just turn off the status bar by setting full screen to true, that gets rid of it. And so definitely recommend you do that. There may be another workaround for it. The thing I want to do is we'll make it our Windows resizable. And the easiest way to do that is I'm going to add my Android manifest template to my project. That just makes it easier to open up an ID. I'll have to save this first. File, Save project as. New folder. Chrome OS test. Okay, so now I have to add my Android manifest, which isn't here yet, I don't think, actually, because I have to build it first. Yeah, I have to build it first. It was in my projects folder, but I don't want to go look for it, so we'll just hit build. And that will create me a new template. There we go. Which I can now add in here. There we go. So right here, this is the line we have to change. So right now it's going to do is going to insert the SDK versions that match the version of Android where native activity was introduced. But instead we want to use version 24. So I'm just going to do this and comment that part out. Okay, so that's all commented out. Now I just delete it. Okay. And we're going to force it to 24. I think 24 is the version that is where the windows are resizable. Okay. And other thing, and you couldn't really see this on there, but this, I believe this is isolated to Intel CPUs. And like I said, the reason I chose an Intel CPU was to make sure that if it works on an Intel CPU, it should work on an ARM CPU. But something about libhoudini causes a slight offset. And the offset is the height of the status bar, which is up at the top of the screen, which I don't see right now. Although I guess if I were to switch to, let's do, right here, this status bar right there, that offset, the size of this offsets all the touches in here. So what we're going to do is we're going to switch to full screen mode. So let's go ahead and do that. Right here, full screen, which gets rid of the status bar, and I think gives you a much better experience on the Chromebook than having the status bar at the top anyway. So we switched to a full screen, and that's going to get rid of that offset. I've talked to product management. They said they do have a bug they're looking at for that because previously Intel Android had been discontinued until this Chromebook was released. They hadn't been putting any look into it, but now they might be looking into it again in the future. So no promises when it'll be fixed, but it's something they are looking at. I'm real excited about Chrome OS, so I'll keep reminding them. So now let's deploy that to our Chromebook. So there we go. It's a whole new application. It will remember your state, whether it's full screen versus windowed for applications. But in this case, it's a whole new application. Let's give it a new name. And because it's set to 24, it runs full screen. And because I set full screen, there is no status bar at the top or bottom. So now I have the full screen is my canvas that I can work with. And I can come in here. And my click's in exactly where the spot where I expect it to, which again, you can't see because it's not showing my cursor for some reason, my mouse cursor. And hello world. And then I come up here to the top and hit the window button. Again, the hello world disappears. And you might think that's a bug, but actually it's not. That's the way Android's designed. Even though the app hasn't restarted, the activity has. So Android apps are designed around the idea that activities restart or go away and come back frequently. So you can't, the program itself can't assume the activity is going to stay running. When we're developing with Delphi or C++ Builder, we assume that activity is there, but the OS can restart it. So I'll show you how to deal with the fact that the activity goes away and comes back. Although really most of the time you're going to run it in full screen mode, and that's what I recommend. But if someone does want to run it windowed, or they could run it, I think it does this like mount on the side thing. Oh, that's Windows 10 that does that. I couldn't remember if it does it on here or not. So all right, let's show you how to fix that real quick. FireMonkey has support for safe state event handling. So you can do that. I'll show you a real simple way to do that. There's other ways of doing this as well. This is kind of the low level option. We're going to go into form create and we're going to put some code down here. And what this does is going to create a binary reader that uses the save state and reads a string from that, puts it in edit1.txt. Now it says I'm using the tpath to specify the storage location. I have to say uses system.io utils, and that will fix that. Now, this is what we're going to do to restore the state, but we have to also save the state, and that is done through the save state event. So go to design view, actually right here, I guess I can just go over here and find the on save state event handler. Double click there and paste it in. And there we go. This is going to save it out. So it's using the save state here to create a stream, streams out the data you want to have. So there's other ways you can do this to not have to manually specify each individual one. I think there's some components out there that makes it a whole lot easier, but this is kind of the low level option so you can see how this works. So let's go ahead and run this on our Chromebook now. So here it is running on the Chromebook, and it remembered my state from last time. So I'm going to come in here and type hello world, and we'll full screen it, and the hello world persisted. I can go back to here as well, and it persists. And the cool thing is actually I can close this and reopen it, and the hello world's still there. Clearly, there's ways you can deal with that if you don't want that to happen, but it's nice that you get that as a side effect as well, so that your user always has the state, whatever they're doing in the application persists in between launching of the application. Pretty cool. Wait, what about C++ Builder? I mentioned this earlier, but all this works on C++ Builder as well. You can use C++ Builder to build Android apps for your Chromebooks as well. If you are a C++ developer and you're curious if C++ works on here as well, this is the C++ device info sample application. We're going to go ahead and run this on Caroline, which is my Chromebook. See, it pops up there. OS name unknown, which is interesting. Device type Caroline. OS version 7.1.1. That's Nougat. Android Nougat. So it's running on Android Nougat. I don't know. It's interesting. I'm not sure exactly how this works. It must be that because Android runs on Linux, and Chrome OS is Linux with the Chrome browser on it. So I'm guessing the Chrome browser and Android are running side by side, which is really cool. But there we go. C++ works as well on Chrome OS. I know. You're waiting for the Linux. And now let's talk about Linux. The easiest way to do this is to use what's called Crouton, which is a Croot. Croot is like a virtual machine, except not really a virtual machine. There's more information about Crouton and what exactly a Croot is on that GitHub page there. So what you're going to do is going to copy your Linux PAServer from your program files folder into Google Drive, and then from Google Drive into the downloads folder on your Chromebook, and then run those commands you see there. After you do that, you're going to need to disable the firewall. You could, what I recommend doing is setting this up with specifically the ports you want to have disabled and then persist it. But I'm going to leave that for you to do. Otherwise, if you use this here, this is a one-time disable the firewall. And then when you reboot, the firewall gets re-enabled. Then you can run PAServer. At this point, it's just like another Linux box, and you can connect to it via PAServer and run your Linux applications. I will point out that you need to be running inside your Croot with the sudo start CLI to run PAServer. You can't run PAServer outside CLI. You can only run the applications that are part of Linux that ships with it. So if you want to run other arbitrary binaries, you need to be running inside your Croot, which you get to by start CLI. First thing to install Linux, we're going to go to shell, and we're going to switch into the root or home downloads folder. You can probably install it elsewhere. All the instructions that they have on the Crouton site are around it being in your downloads folder, so that's what we're going to use. And we'll use wget to download it. This is the latest version as of this video. And this is an uppercase O, not a 0. It has to be uppercase to rename the output file. So there we go. We've saved Crouton, and now we can run it. And running it is going to download the latest installer and give us a list of commands, what we can do here. So let's take a look at the targets that we can use, which is going to specify the different types of croots we can install. So we'll just come here and we'll say -t list. This is a list of all the different croots we can install. I'm not sure why that flickers like that occasionally. So we're going to install CLI Extra, which is core plus some extra command line stuff, because all we need right now is command line. If you're wanting to go for a full desktop environment, you can use GNOME, GTK, lots of different options there. That flickering is annoying, but hopefully you get the idea. So let's go ahead and do CLI. So you get that warning every time. Notice it says AMD 64 because I'm running a Linux 64. If you're not running 64-bit, I'm running an Intel CPU on the Samsung Chromebook Pro. If you're not running an Intel CPU, you can still install Linux, but it's not a valid target for Delphi. Delphi supports Intel Linux, Intel 64-bit Linux, not ARM Linux. So it's taking a while because it has to download all these libraries and packages that it needs to run Ubuntu Linux on top of this. So it's not a virtual machine, it's a Croot, which is something I wasn't familiar with until Crouton. A Croot it's a separate file system, it's a separate set of binaries. But it's not a virtual machine. So it's more efficient than a virtual machine because it uses less memory, but it's not as secure as a virtual machine because you're still using the same RAM. Okay, that took a while, not too terribly long. So username for the primary user, I'm going to go ahead and go with, I will say Delphi. Okay, so we're all done. We've installed Crouton, and we can launch a new command line interface by typing sudo start CLI. So now we're in the command line interface. So I think we should be able to go shell sudo start CLI. Oh, did I type the wrong thing? Oh, it's all like that. So now we have two command line interface terminals set up. So there you go. We've installed Linux now. This is all, at this point, we're in a full Ubuntu command line interface. So whatever you could do in Ubuntu command line interface, you can do now. I believe for the most part. I messed around a little bit. It seemed to work to me. I've also tried some of the graphical interfaces as well, and they worked quite good too. If you want to make sure you're running on Intel, you can use the uname command, and you can do this from I'll just exit back out. So now I'm back in Kronos, which is the shell inside Krosh. Uname -a will give you the full all of it, or uname I think it's M. Yeah, uname M. See how it says x8664? That means I'm running on an Intel 64-bit, which is what you need to have in order to target it from Delphi. To run PAServer, the easiest way I found to move it across is to use Google Drive, since I've already got Google Drive support built into my Chromebook. So I'm just going to grab my Linux PAServer and drag it to the local downloads folder and copy it over there. So there's Crouton, which I installed earlier, and my PAServer. So now I'm going to go to a terminal window. Go to my downloads directory. There it is. tar, xvf, Linux, and we'll go into the PAServer folder, and we will run PAServer. Now you notice I get permission denied. That's because this is one of the limitations of the built-in command line interface. So that's why we're going to use crouton. So we're going to say sudo start CLI. And now we're in crouton, or crout, and we can go into the downloads folder, PAServer, and run PAServer. And it's running, so I'm going to put my password in here, and it's running on port 64.211. Now, I can't connect to that port because there's a firewall in here, and right now the firewall only lets in port 22. Now, I could modify IP tables to let in only port 6420 or 2211, but I also want to maybe build an HTTP server or whatever. So I'm just going to say, you know what? I'm on my internal network. I feel safe, so I'm going to disable my firewall completely. And it's using IP tables, so I just do sudo IP tables -f. So now I've completely disabled my IP tables firewall. So I can go back to my PAServer, and now we're going to jump over into Delphi and create a Delphi application to run on our Chromebook. This is a simple console application. I've set it to Linux. Come in here, edit connection, and 10.0.1.36, hit test connection, succeeded successfully. If you get an error message, you either got your IP address wrong or you left your firewall enabled. And we'll just run this bad boy here on Linux. And there it is. Hello, Linux. So it's ran. At this point, it's just regular Linux box. Let's go ahead and do a server. Close all. Same changes as project 32. No. I'm going to create a new other web broker. There is web broker server. And we'll say Linux. Next. Standalone console application. I guess in theory I could install Apache on there. Probably could with the crouton. And finish. There we go. So let's go ahead and just deploy it. Target platform, Linux. So we come over here. We've got the window pops up. So we're going to type start to start it up. I got to type start. There we go. Starting HTTP server on 8080. So now the server's running on port 8080. And I can fire up my browser and go to 10.0.1.36 port 8080 and 10.0. What did I do? Oh, 10.0.1.36 port 8080. Web server application. So there we go. We've connected to our web broker server running on our Chromebook. So at this point, it's another Linux box that you could develop on. It just happens to be really small, lightweight, and have a touchscreen. Okay, so what about the future? Now, I'm not in product management, but I talk to product management a lot. Chrome OS is not an officially supported platform yet. Okay, it's not on the official roadmap. I told them, hey, look, this should work. And they said, oh, go find out. So I got a Chromebook, tried it out. I said, yep, this all works for the most part. I told them about the offset. And they said, yeah, we remember that one from when the Intel Android was supported years ago. Well, not years ago. It feels like years ago, right? About a year ago, I guess it was. And they had an issue on that. So they're looking at possibly fixing that one and as well. So my tests showed that it works fairly well today. Certainly enough that you can be aware of it as a platform that your devices will be running on. So definitely something to keep in mind. And it may show up on future roadmaps. So show up on future roadmaps in the future. I say future twice there, but you get what I mean. For more information, the main link there at the top, embt.co/Delphi Chrome OS, is the main page. It will link to all the other links you see here. But if you want to find out more about Chromium, which Chromebooks are supported, and how to get in development mode, stuff like that, check out chromium.org. The Google developer page for Android on Chrome OS tells you about how to set up ADB, some of the different concerns you will have around developing Android apps that target Chrome, and what you need to know there. That's where it talks about how to make your Windows resizable. And then I have the 3 different guides I've put together you can get to directly via the links you see there.